All right, Algebra 2 Finance students, we're moving on to 7-7. This is the last section in Chapter 7. So later on this week, we're going to have a Zoom meeting. So I'll post all that in Google Classroom, and then we'll take some notes in the Zoom meeting. We'll have a study guide, and we'll have some type of assessment on Chapter 7 since we're at the end of a chapter. We're going to break this down into 2 days. So the first day, we're going to talk about Pythagorean theorem and slope, and day 2, which I'm highlighting here, we will talk about inverse trig functions and angle of elevation. So this is day 1 and then day 2 there. So let's fill in some blanks. So make sure you have your chapter 7 packet and then stop the notes, stop the video, try those on your own, and then start it back up again and check your work. So a homeowner will need to know how to repair, a lot of words you can put here, live in, upgrade, their home, and will often use measurements in triangles to assist them. The field of mathematics that involves measurements in triangles is trigonometry. So they both got the word try in there, 3. Okay, and you'll be surprised, I don't know if any of you guys are into woodworking or have ever worked on any projects, building stuff. I just built some attic storage, and I needed to cut some beams to the right length and support it, and to support some plywood. And I did use a couple of these formulas that you're going to learn today, along with some other tools. So example number 1. Anna is planning to build a 15-foot by 20-foot rectangular deck off the rear of her house. She is going to put stakes at the corners of the plot and lay string from stake to stake. She wants to make sure that she has a perfect right angle to start. How can she do this? Okay, it seems relatively, easy. So this is the house, and she wants to lay stakes, it says, at the corners of the plot. So maybe she'd put a stake right here. But how do you know that this is exactly a right angle? Maybe she walks slightly this way and puts a stake here, or slightly this way and puts a stake here. Seems easy, but it's not as easy as you might think to make an exact 90-degree angle if you're, want to build a deck. So you can use something to help you here. You can use a Pythagorean theorem. So this is the house. This is the deck. It says she wants to make this 15 by 20. We'll just assume this is 15 and 20. And you want to make this a perfect right angle. How can you do that? Well, you can't just walk off 15 feet this way and walk 20 feet this way. Guaranteed you won't get a right angle doing that. Okay, you got to have some type of measurement going on. So what you can do is you can figure out what the diagonals of this are. Let me use a different color here. So we'll use this blue diagonal. And in order to figure out this blue diagonal, I would use Pythagorean theorem. Okay, so just representing this a different way here. This is 20, this is 15. And if I figure out what this is, I could then cut a piece of rope or string or measure it, measuring tape, whatever it is, and I could lay that out here and lay it out here. And if I start exactly in this corner over here and lay this string out and I measure this distance, I can meet up these two edges right here, one that's 15 feet long and one that's the length of this that we're going to find out. In order to do that, we got to use Pythagorean theorem. So we're going to use a squared plus b squared equals c squared. So my a and b value are the legs of the triangle. I'm sure you've heard about this many times from 7th grade on up. So I'm going to do 15 squared plus 20 squared equals c squared. Okay, and c is going to be my hypotenuse. So this is going to be 225 plus 400 equals c squared. And I get 625 equals c squared. And if I take the square root of that, I get 25. Okay, so this diagonal is going to be 25 feet. And this diagonal is going to be 25 feet here. Okay, so we'll do that in green. So this is going to be 25 feet. This is going to be 25 feet. Another thing that you might recognize here, these diagonals, they're going to intersect at the midpoint. So if you were to mark this out with string like she's doing, you might mark this at 12.5 feet right here and 12.5 feet. And wherever those meet is going to be the middle, and the end of this would make a perfect or close to perfect 90-degree angle, depending on how accurate she is there. Okay, so that's one way you can do it. You can find the diagonals and use that to help you. All right, so more complicated than you might think. Ivana measures 6 feet along the house, and her friend held an 8-foot-long piece of string at a right angle. How long would the hypotenuse be? So go ahead and try that, and try this extend your understanding problem. So pause the video, try those two, and then check your work. All right, assuming that you pause it here. So she measures 6 feet along the house. So maybe this is the whole house. This represents, 6 feet of it from here to here in orange. And her friend holds an 8-foot-long piece of string. So this is 8 feet. What is this hypotenuse going to be? So again, we have the legs of the triangle, and we're trying to figure out the hypotenuse. So we use Pythagorean theorem. A squared plus b squared equals c squared. So we got 6 feet plus 8 feet equals c squared. Okay, so this is going to be 36 plus 64 equals c squared, which is going to be 100. And I know the square root of this is going to be 10. Okay, so the hypotenuse would be 10 to answer that question. Let's move on to the extend your understanding. Again, pause it and see if you can get it. When Anna's 15-foot by 20-foot deck is fully plotted, she wants to double check all of her angles to make sure that she has a rectangle. The opposite sides are congruent, but parallelograms that are not rectangles also have their opposite sides congruent. The only parallelogram with a congruent diagonal is a rectangle. She checks both of her diagonals. If the figure she marked is truly a rectangle, what is the length of the diagonals? Okay, well, we kind of already figured that one out. So the extend your understanding, the answer is 25. Okay, so again, how can she be exactly sure that this is a rectangle, that all of these angles are 90 degrees? Well, she could measure with a tape measure or a string a diagonal, measure another diagonal, and if these intersect each other at their midpoints, then that means that the angles have to be 90 degrees. Okay, if that is the midpoint right here. So that would be the midpoint. And if the midpoints intersect, then you can do that. And the way you would do that is you would just take your measuring tape, and you can mark where, if this was 25 feet, you would mark where 12.5 feet is for one diagonal, and you'd mark where 12.5 feet is for the other diagonal, and match those up. Okay, example 2. Manny is hiring a roofer to do some work on his house. The steepness of the roof will affect the labor cost he is charged. Interesting. I haven't heard of that before, but I guess the steepness means it could be a little more dangerous to stand on the roof. But below is a side view. I guess the steepness could affect how much material there is, maybe, because it affects perhaps the length of the roof. Anyway, below is a side view of Manny's roof. How can he mathematically describe steepness? Well, steepness is the exact same thing as slope, which you can also call that pitch, which is rise over run, which is the change in y over the change in x. This little triangle is the Greek symbol delta, means change. which is the same as the variable m in slope, which is also the same as the formula we're going to use. So all of these things, y2 minus y1 over x2 minus x1, these all mean the same thing. Okay? So it says, how can he mathematically describe the steepness? Well, he would need to do some measuring. So he could measure this run right here somehow and measure this rise. And if he figures out what the rise over run is, what each one is, he could mathematically describe the steepness. Okay, moving on to the check your understanding. So a steep roof on a Victorian house has a rise of 19 feet and a run of 12 feet. Is the pitch greater or less than 1? So we have slope, which is m, or in this case it says pitch, is rise over run. And the rise is 19 feet and the run is 12 feet. So is it greater or less than 1? Well, 19 over 12 is clearly greater than 1. So 19 over 12 is greater than 1. So the answer is greater than. Okay, extend your understanding. If you are graphing lines in the xy coordinate plane, so xy coordinate plane is just this thing right here. The formula for the slope between two lines is y2 minus y1 over x2 minus x1. Find the slope of the line that passes through these points. Well, we would label our first point x1 and y1, and our next point x2 and y2, and we would just find the slope. Slope is going to be negative 20, y2, minus y1, which is 4, and x2 minus x1. And we would get negative 24 over 4, which is going to be negative 6. Okay, so very steep slope there. So the slope is going to be negative 6 on that one. All right, I'll post the homework on here, and I will see you guys in our Zoom meeting later on this week, first Zoom meeting.